So my derivative is positive here, and it's as I get closer and closer to that maximum, that slope of the tangent line is going to get smaller and smaller. Still positive until it hits zero. The same thing's happening on the right side of this minimum. So it's going to start off, my derivative is going to start off pretty small, but positive, and then starts to go big. So I'll end up with something that looks like this. So that looks like the tail ends of my quadratic. I just have something happening here. When we were thinking of our second derivative and second derivative test and concavity and inflection points, I knew my inflection point would be somewhere about here. That's where I'm changing concavity. So this should be my inflection point, which is where my second derivative is negative. That means if I'm thinking of the derivative of my derivative, it should be a local max or a min. In this case, it should be a min because my function is decreasing on that interval. So I'm just going to place it here. Again, it's not anything deep of why I put it at -3. You could have put it at -2.5, -1. Just make sure this, as the lowest your quadratic goes, is about that inflection point, and that you end up with the quadratic function. So it should be the lowest it goes. I have a negative value here. Should look something like that. Again, it doesn't have to be perfectly aligned to where I'm at. My second derivative then, we'll take a look at my first derivative. I can totally ignore that first graph pretty much. I'll change color here and play the same game on my first derivative as I did on my original function. Um, Essentially, this is going to turn out almost exactly like the first example. The difference is where I'm located. So I'm going from a quadratic. The derivative of a quadratic is a linear. I have a local min at x is equal to 1. So that's where my derivative is 0. So I kind of like having this piece here just to kind of help me organize. I have no local max, so that's the only place that I know for sure is going to be on my second derivative. From here, going into that minimum, my function is decreasing. Anywhere my function is decreasing, my derivative is going to be negative. And then on this side, my function is increasing. Anytime my function's increasing, my derivative is going to be positive. And again, as I get closer and closer to that minimum, my tangent line is going to get closer and closer to 0. So it's going to be decreasing, getting closer to 0, and then increasing from 0. On that side, increasing as negative, but getting closer and closer to 0 as I hit that minimum. And then positive on this side, getting closer and closer to negative as I'm getting closer and closer to 1, or I'm growing as I go up that way. The awesome thing is I can then check my work. So for this piece, I have a 0 in my second derivative. That means that I should have an inflection point at x is equal to 1. And then I can talk about concavity on my second piece. So you don't actually have to do these pieces. It's just a nice check of your work. So I have an inflection point where my derivative is 0. My second derivative is 0. My second derivative is negative here, which means that my first function, my original function, is concave down. Second derivative is positive here, which means that my original function is concave up. And I can check on that. So from negative infinity to 1, I should be concave down. From 1 to infinity, I should be concave up. And if I scroll back up, that's what it looks like. I'm concave down all the way here. I have that upside down bowl all the way up to -1, and then it flips over there. So I have an inflection point here. I have concave down over here and concave up over here. So a good check. The other thing that you can use is that first derivative. I have a 0 here, and my function's going from positive. Sorry, my derivative is going from positive to negative. my original function's going from increasing to decreasing. So I have increasing to decreasing, that means I have a local max there. Same thing here, local min, I'm going from decreasing, my derivative is negative, to increasing, my derivative is positive. So again, there's no exact science to this one outside of identifying critical points and, if possible, inflection points on it. We'll get more practice in class on the next day I see you. Please, please, please bring your questions as you have them. Thanks for watching.